Good afternoon, good morning, good evening, depending on where you are on this fast-forward planet, which is wrapped in layers of turbulence. Many of them are interrelated, climatic, geopolitical, economic, and in the United States, pure politics too is emerging as a big issue for science-based policy, whether it's health or climate or disaster risk, you name it. There'll be lots of challenges and hopefully productive conversations going forward. I'm Andy Revkin. This is the Sustain What webcast, and today we're going to talk about CH4, methane, this gas that is the second most important greenhouse gas emission from human activities that relates to the fate of the climate. You know, we are heating the climate. There are various compounds that if you put them in the air, they stay there for a long time. They have an influence on the balance of energy coming from the sun and heading back into space. And that's it's been a big deal. I think for journalists, we've been focused on the fossil fuel emissions and landfills, things that are sort of discrete. And the science has kind of expanded the picture toward but there's always been this question of, well, three things, and you're going to hear a lot more from the scientists here. It's like a bathtub, just like with CO2. You have different sources. It's being destroyed. Methane gets destroyed in the atmosphere pretty quickly compared to CO2, way quicker. But it's still, it's very powerful while it's there. So that's the key. And we're just going to dive right in. Today, I've got Rob Jackson, who I've interviewed and known as a source on this issue for decades, literally, and Sylvia Michel, who's in Boulder, Colorado, works at the interface of NOAA and University of Colorado Boulder, and does sort of the lab end of things. And Rob is kind of the big picture focus. He has a book out as well that you'll learn about. And so the idea is just to cut through some of the sort of, I won't call it spin, more noise around methane, to clarity on what we can do to understand it better and to get at the sources and to maybe speed up the sinks and go forth. So I wanted to ask you both initially, just like what got you focused on this particular compound in your work? You know, you have skills that could be applied to anything. So Sylvia, first, you know, what about methane fixates you, and what's your part of the science?
Sure. So I'm, like you said, at the Institute of Arctic and Alpine Research in the Stable Isotope Lab. And we've been collaborating with NOAA's Global Monitoring Laboratory for many decades now. I think we started measuring isotopes of carbon dioxide in 1990. And then we started measuring carbon isotopes of methane in 98. So we have a pretty long record now. And when I started 20 years ago, which is crazy that it's already been 20 years, but we measured delta C13 of methane, which is this weird unit that reflects the ratio of the heavy isotopes to light isotopes in the carbon atoms of methane. I know some of your audience maybe hasn't thought about thought about isotopes since their high school chemistry classes. So we're looking at the heavier version of this molecule relative to light version. And so we were measuring that through, since 98 and until 2006, 2007, it wasn't changing that much. We could see seasonal cycles, but not a lot of year-to-year differences. And then starting in 2007, 2008, it started to change more negative. So relatively less carbon-13 relative to carbon-12. And at first I wondered if there was something wrong with our instrument or if our calibration tanks were changing or something like that. But then after doing all of our quality controls, we realized that it was real, and our collaborators in other isotope labs across the world were seeing it too, which is very validating for us. And so then we realized that this was a real signal, and we needed to make sense of it. So there have been many papers over the years using our data. And then since 2020, that change in the isotopic ratio was becoming even more dramatic. And so that's what prompted this recent publication where It's very data centric. We just look at the signal and we show comparisons with other labs that see the same signal. And then we use a very simple but elegant model to quantify like what could be driving these changes.
And this again, and Rob, maybe you could weigh in. Let's get Rob's answer to that basic question: why methane? And then, your take on this shift in understanding of the source mix and how that's reflected in the chemistry and the like.
Yeah, the why methane part is interesting. It's the second most important greenhouse gas, as you mentioned, Andy. It's 2/3 as important as carbon dioxide in sort of a several decade time frame. I have come to focus much of my research on methane because it's the only greenhouse gas for which, if we could reduce emissions today, we could actually see the atmosphere restored to pre-industrial concentrations within a few decades, within the lifetime of people listening to this webinar. There's no other greenhouse gas for which that's possible. And if we had a magic wand and could eliminate anthropogenic emissions, we could save 0.5 degree C of warming within a few decades. And it's the strongest lever we have for slowing climate change over the next couple decades.
And that's because while it's in the atmosphere, it has that particularly powerful heating effect, and it's transitory. It gets broken down. So if you stop the emissions, it goes away.
Yeah, it's super potent, and compared to carbon dioxide and nitrous oxide, quite short-lived. A decade or a little bit more on average, and instead of thousands of years for carbon dioxide and hundreds of years for nitrous oxide.
And I think it was maybe in the thing you wrote for the conversation with some other authors, or somewhere I heard that in the carbon finance world, like only 2% of the money goes to,
that's right. Yeah.
The focus goes to the methane side of the equation, despite what you just articulated.
Yeah. Methane's been neglected for decades. Not only has a trivial amount of climate finance gone to methane mitigation, but the first global methane agreement was only signed a couple years ago. We've had decades of agreements for carbon dioxide and other gases, but we're just waking up to the importance of methane. And I think it's partly for the reason I mentioned earlier. People are looking around asking, what can we do on a time frame of a few decades? And there isn't a lot for the Earth system, and methane's one of the strongest levers.
That's so interesting. So before we get back into the policy implications, and we will, and then into your book, I want to get back to this basic understanding of sources and stuff. I had another paper here. Where is it here? I don't think you're author. Oh, Sylvia, yeah, you're an author in this one. So the tropics too, it's not just sources, meaning it's more biological, but it's also more tropical. How do we know that? I think there was one of the questions that came in was about that. How can you kind of get geographic in thinking about this?
Well, one thing we do is we look at latitudinal gradients, right? So both the methane mole fraction and then the isotopic ratios, and then we can look for changes in the latitudinal gradients. And there has been a lot of attention to the warming Arctic, and for sure the Arctic is warming at troublingly high rates, right? And yet there are huge sources of methane coming from tropical wetlands, which are warm and wet, right? And getting warmer. So the tropics are definitely a big deal.
Can you weigh in on that? What maybe just clarify a little bit about perceptions. Again, the media, we focus a lot on things like fossil fuels because fracking became a huge issue in the States and in Europe, where they kind of banned it. And fossil fuel companies make a convenient target when you think about climate change because they're the ones extracting the stuff we're all burning. But at the same time, the science seems so different. What do you think? Could you just lay out your perception of that gap between the average person you run into and what's real?
It's true that the fossil fuel industry gets most of the attention or the focus, and our new paper, we just estimated through the Global Carbon Project that 2/3 of all methane emissions worldwide now come from things that people do. So that's
Right.
the methane cycle has been perturbed far more than any other greenhouse gas like carbon dioxide. But about 1/3 of those emissions from human activities come from energy and fossil fuels primarily, but about 2/3 comes from agriculture and waste. So cows burp as much methane as the oil and gas industry emits. Rice farming releases some methane. Waste, food waste, landfills and such
Yeah.
are a major component. And then there's the largest natural source is wetlands, freshwater ecosystems, and they seem to be increasing, particularly in the tropics. We expect that to happen as temperatures warm, because warmer temperatures boost the activity of microbes. But we didn't necessarily expect to see it already. But in the last few years in particular, there's strong evidence, including our paper out a couple months ago, showing hotspots of increased emissions in the Congo, in the Amazon, in the Pantanal in Brazil. It was work done by a postdoc, Zhuiying Yu, and others. So we expect tropical emissions to increase, and we're starting to see that increase now. And whether that continues remains to be seen. But it's troubling. We have no way to slow those emissions. I sometimes say you can turn a wrench in an oil field, but there's no wrench to turn for the Amazon or the Congo.
Right. And that gets to something else you've been talking about, which is actual drawdown for methane too. In other words, are there ways, we all, well, not we all, those who are focused on the climate problem have seen a lot of discussion of carbon capture and sequestration, for example, which is really hard to do at a scale the climate will ever notice, to my mind, after talking to so many people about it. But it's important work to consider. I think there's been way less discussion of methane, active methane destruction, drawdown. Maybe I'm kind of jumping around here a little bit, but it certainly relates to what you just said. If you have these giant sources that have no wrench,
Mm-hmm.
Could you just talk about that as a possible reality going forward?
Yeah, one of the tricky things about methane is that the place to start is with the super emitters, the oil and gas facilities,
Absolutely.
the landfills, the things that you can see from a satellite, satellites that have just launched this year, in fact. So that's
Yeah.
the place to start. But most emissions worldwide don't come from those super emitter sources. They come from more dilute sources, from wetlands, from single cows, from rice paddies and things like that. So we need approaches to reduce those emissions too. And methane removal from the atmosphere is a possibility to do that. It's really very hard. It's not clear that we can do it at scale yet. The National Academy just released a report this summer, a committee that I was on, and we recommended a research roadmap for the next 5 years. But we really don't want to have to rely on that for the future. And because methane disappears so much more quickly from the atmosphere, in principle, we don't need it in the same way we need it for carbon dioxide. If I had a magic wand that I could end CO2 emissions today, there would still be 1 trillion tons of pollution in the air in thousands of years for CO2. And that's not true for methane. A magic wand eliminating emissions would see the atmosphere go back to health within a few decades.
Right. And Sylvia, can you weigh in on this from the context, not just of you, but from the people you work with?
Yeah, I think it's a tricky message that we as scientists have to convey, because so I can see who has blogged the paper that we just put out, and some of the people were saying see, it's not fossil fuels. Fossil fuels are not the problem.
Right.
But of course fossil fuels are the problem, because it's still about 40% of methane emissions are from fossil fuel extraction and transportation, et cetera. But then the bigger problem is the carbon dioxide released from fossil fuels, right? So Rob is right that because methane has a shorter lifetime, it's a great target for, acting quickly to delay the climate change that will happen in the next few decades. But we're not going to solve the problem without addressing fossil fuel emissions. So it is a pretty tricky message to convey, because yes, we need to stop the leaks from the fossil fuels to prevent the methane releases, but it looks like the recent emissions are from these harder to mitigate sources like wetlands. Maybe we could do better. I'm sure we could do better with landfills, and then maybe we need to rethink ruminant agriculture and
Right.
what are the consequences of our diets and the way we raise cows and handle manure and all those things. So I guess we need to make sure that with the limited resources that we have, how can we best use them to address these big problems? So
Yeah. And this is an arena also where historically there's been this thought of using markets, carbon offsets, credits, and the like. It's been very problematic. And I don't know whether there is another approach. Rob, you've dealt with the policy questions here too. If you have a diffuse problem with multiple solutions, is a lot of people talk about markets right away. There are credits being sold by farmers for reducing methane, I think, in some parts of the world at least. But it's hard to it feels like it is kind of tough and multidimensional. I don't know if that seems like it's part of the solution or not.
Yeah, it's hard to quantify. First, I want to amplify something Sylvia said. The place to start is in the fossil fuel industry, because every time we reduce burning a fossil fuel, we don't just save the carbon dioxide emissions, we also save the methane that leaked out in the oil and gas field where those fossil fuels were extracted,
Right.
or coal mine, all the way through distribution and use. So in spite of these diffuse sources being really important in the realm of methane, energy use in fossil fuels is still the number one place to start for both carbon dioxide and methane. But this, we're struggling a little bit with understanding cause, which we'll come to, but also responsibility. If emissions increase in the Congo, the last few years in Africa, in Central Africa, have been both warm and wet, which is a perfect sort of engine for boosting methane emissions in wetlands. And we're seeing that increase. But if they increase in the Congo, or they increase from tropical wetlands in the Amazon, like where I work with partners, is that emission attributable to Africa or to Brazil?
Right.
It's really that's really not appropriate, because that boost is coming from warming that's driven by greenhouse gas emissions. So you get into this issue of temporal responsibility versus other responsibility. It's very complicated.
Yeah, and actually that also, if you bring in the precipitation part, the climate models are pretty bad still at precipitation in the tropics. I've been talking for years to people about sub-Saharan Africa, about the models competing, showing a drier zone just south of the equator, south of the Sahara, or a wetter one, and supercomputer models haven't figured that out. So that would lead to away from some kind of coherent measure of who's responsible. At the same time, I mean, the no-brainer part is just a no-brainer. Like, I did that story in 2009, front page of the New York Times, using infrared imagery. The EPA was showing, the leakage from fossil fuel infrastructure is so ridiculous. And I interviewed people in the industry at that time, Shell, I think, BP or Shell, oh gosh, in New Mexico. They had a guy running around the world trying to encourage all of their operations to leak less methane. And they had a cultural shift where they actually got the emissions way, way down, because he was basically saying, don't give me a number like 20% better, just keep going. It's not like there's a threshold here. You go to zero. And I hope that the culture can shift in the fossil fuel industry more in that direction. I certainly, and then there were some analyses that showed it actually made money. If you keep it in a pipeline, then you have something to sell and combust.
I think there's evidence that that's working. There are, even though fossil fuel production has gone up, methane emissions from fossil activity seems to have decreased. There was recently a paper by Kushal Tibrewal showing that the proportion of emissions from fossil fuel extraction has gone down in a lot of countries.
That's encouraging.
Call me a little more skeptical than Sylvia on that case. I'm not sure that the industry's estimates of what their methane emissions are are vastly lower than the scientific community's estimates. And I think we're going to find with the satellites and other tools that I think we'll find that emissions from fossil fuel extraction and use are higher than we have thought in the past.
But I think both things can be true. They can be higher than their bottom-up estimates, but they can still be decreasing over time. Would you agree with that?
I would agree with that, and I think it's true that the atmosphere is telling us that the increases are more biological. They're lighter, which is part of Sylvia's work. But I'm not sure that means that fossil emissions are necessarily going down. It doesn't have to be the case. So I'm just a little skeptical that the evidence for the decrease in the oil and gas industry is not that strong, in my opinion.
Well, and it's hard to go drive by the fracking operations that are still in the Denver-Julesburg Basin and not be convinced that there's some methane release from all that activity, right? So, yeah, it's hard to make sense of.
Yeah, although I think, as you were saying, the satellite and other aerial sensing that's been done has clearly, I've seen papers on this, including from the EDF project where they were working with the industry, that show the dominant sources, these super emitters, are really across that whole landscape you're describing of emissions. The role of super emitting sites is clearly key, and that implies there are discrete solutions that can be illuminated through the use of remote sensing to sort of point the finger, and then well, what do we do on the ground? What are the solutions there? I'm hoping that that's how this can all work. I've written many times about the idea that an observed Earth, a monitored Earth, can be a safer Earth. I just was writing that in the context of tsunamis, but it's true. It's true for we're in an age where you can impose transparency in ways that were really not possible 40 years ago or even 10 years ago. I think
that's what's so, sorry to jump in. That's what's so exciting for me about the satellites is that we'll have a better and clearer picture of operations in the United States. And there'll be fields like the Permian and the Bakken that are primary oil fields that I think will learn that emissions are higher than we think they are. And that has been shown in other tools, using other tools too. But we'll also be able to see Russia and China and Azerbaijan. There's nowhere to hide from a satellite. And that there's a power in democratizing that information.
Yeah, and I'm showing this is the Google Earth Engine data output for MethaneSat, which is there are a couple of new satellites, but this one, you can dive into these basins. It's early days because this still just come up. These satellites are just coming online, right?
And the carbon mapper, it's more of a zoomed in version.
Right. Carbon mapper is really cool. In fact, one of the images I showed earlier, I think, is from them. So that gives me great hope as well on that industrial component. And of course, it depends on the country, as you say. That piece I did in 2009 about the possibilities of emission reduction. Someone I interviewed for that New York Times piece had been to a single Russian gas hub where one compressor or something, he estimated it was leaking as much as all of Canada's infrastructure.
Wow.
It was, but we'll have clarity. So maybe that's an overstatement, but there's a capacity to know that. I wanted to get into a couple of other angles here. So just hold on a second while I shift gears. It would be worth going into a little detail on this thing called the Carbon Project, the Global Carbon Project, and its role. It has a big section on methane, but who is it? How does it work? What's the goal, et cetera?
So in the Global Carbon Project, which I'm fortunate enough to chair, we organize thousands of scientists who contribute to what we call budgets. We analyze emissions and sources and sinks for carbon dioxide, methane, nitrous oxide. We're working on a new hydrogen budget. We assemble bottom-up sources. Estimating how much of a greenhouse gas is emitted from point sources. We look from the atmosphere down, the approach that Sylvia uses. We put all these pieces together and attribute emissions and rising concentrations to natural sources, human activities, and try and provide all that information in a transparent and easily usable way for policymakers. That's it's a favorite thing I do professionally.
That's good. And let's talk about the cross-disciplinary aspects of this too. Here we have Sylvia. What's your actual PhD in?
I don't have a PhD.
Oh, that's right. You have a master's. I remember looking.
I have a master's degree. I'm actually I'm taking classes. I'm hoping that late in life I can get that degree that I didn't get in my 20s. But I was hired 20 years ago as a lab technician. So I run the instruments that make these measurements. They're isotope ratio mass spectrometers, and then we have prep system that extracts the methane from the air. It's a pretty complicated process. It is not an easy measurement to measure methane isotopes. Carbon dioxide is a little bit easier, but we're trying to do it at very high precision and very high accuracy because, in the time that I've been in the lab, honestly, since measurements began in 1998, the delta C13 of methane, which is that weird unit of the isotopic ratio, it hasn't changed by very much, right? A couple, a per mil at most, right?
Yeah.
So, and that per mil is, we're talking about 1.061% versus 1.062%. This is tiny changes in the ratio. So anyways, my job is to make those instruments run well. I work with a team of folks who are doing that, and then to manage the data. And then I work with colleagues at NOAA to make sense of the data. So the Global Carbon Project doesn't use the isotopic data. Is that correct, Rob? Historically, you guys haven't really used that in the studies, and
we use it in our inversions now, at least in some of the models.
Oh, cool. Okay. So yeah, there's not a ton of isotopic data available because it's a difficult measurement. But it's a very useful constraint because when you make hypotheses about what is changing in the methane cycle, the isotopes allow you to test those hypotheses, right? And that's what in our simple model in the paper we show. If you attribute all the methane increases to fossil fuels, which is our favorite villain, then it just doesn't make sense with the isotopic data. So I sort of feel like my contribution to this problem is to make the measurements that allow you to then say, does that make sense with the hypotheses that other groups who may or may not be using isotopes are coming up with, right?
Yeah.
So I think what's kind of neat is that there's been so much disagreement or so much conversation, debate among our community for many years, but there is a little bit of consensus building, I think, about the importance of these microbial sources, even though we all recognize that fossil fuels are still a big part of the methane budget. And then, of course, the bigger problem when it comes to CO2.
And, so one question here is there more, how can the picture and policy choices get clarified with more interdisciplinarity? Is there anything missing in terms of the conversations across disciplines? I found this to be the case sometimes with paleoclimate and climate modelers and field observers. They just don't talk to each other, or sometimes they talk in different languages, and I see missed opportunities there. To improve climate models, for example, with more historical data. Is in this arena, is it sufficiently cross-disciplinary? Anyone missing? Maybe Rob first.
Yeah, it's a great question. I would just begin by saying we use Sylvia's data and the NOAA data, and so we're grateful for having it. I'm worried about monitoring in the upcoming change in administration. Monitoring is an easy to cut. So one of the things we shouldn't do is let any of our monitoring stations disappear because it's convenient, and we really need more monitoring in places like the tropics and the Arctic where we expect changes to happen. In answer to your question about multidisciplinarity, I think the biggest gap is the intersection between the natural and physical sciences and the social sciences. Climate change is primarily a behavioral issue at this point, in my opinion. The technologies are out there, but human behavior is hard to predict and motivate. So the biggest gap that I see is the need for connections between the natural and physical sciences and the humanities and social sciences.
I couldn't agree more. I've seen this over and over too. In fact, when I started writing about global warming in the 1980s, I really was just doing the science journalist thing. CO2 is a greenhouse gas. It behaves this way in the atmosphere, blah, blah, blah. And a little bit on the treaty and policy. But it took me 18 years before I interviewed my first social scientist. It was like 2006. I'd already been on the, writing about this stuff forever. And then it was like, oh my God, this is really important. Even as a journalist, thinking about how information does or does not change behaviors.
Mm-hmm.
That research was sitting there and I hadn't really absorbed it myself and thought, oh my God, this is really something else. Which takes us to the next chapter of this conversation, which is about your book. And, it's not there've been a lot of climate books recently, including by climate scientists. But what drove you? Well, let me back up and say you've written before. You actually write poetry, Rob, and other creative output. But what drove you to write a book about this called "Into the Clear Blue Sky"?
A couple of things. One is just the desire to reach people, to make scientific information accessible for people, and to try and change the dialogue in that way. I had a sabbatical with a group of behavioral scientists, and in their world, writing a book is sort of the culture of the realm. But my book's, as you mentioned, called Into the Clear Blue Sky. I think of it as a how-to manual, a source of inspiration in climate solutions, in a journey from what I call climate despair to climate repair. So it's a hopeful book. It chronicles people, companies, organizations who are really making a difference today, and tries to say, we know what the problem is, solutions are out there, and a world with climate solutions and clean energy is a healthier and safer world for us in rich nations and especially in poor nations. So it's a quest. Think of it as a quest for optimism. I went searching for inspiration, if you will, and found it in many places around the world.
And what got you digging in with social scientists and behavioral scientists? How did that happen?
It's funny. I did a sabbatical at an institute called the Center for Advanced Study in Behavioral Sciences, and I was sitting at a table early on with one of the board members, and he asked me, what are you? You're a neuroscientist. What are you doing here? And I said, well, I came here to learn about the behavioral sciences, and because I believe that behavioral sciences provide the solutions to climate change more so than sort of the technological sciences. And he looked at me and said, well, I disagree. I'm a behavioral scientist, and I'm hoping that the technological scientists will fix climate change. So that was sort of an interesting interaction. But it was to learn about human behavior and to understand the systems on Earth better.
Interesting. And is there some nugget in your wanderings? I've only sadly had a chance to scan the book, just because I've been overwhelmed with other work recently. I am going to be reading it, but in this,
I won't quiz you.
What's your if there's like 2 or 3 little anecdotes or even 1 or 2 that you think really kind of make the point for not just optimism as a state of mind, but really concrete steps people around the world are taking? What comes to mind?
Yeah, thanks for the question. A couple of things come to mind. One of my favorite chapters is their chapter 11 called Repeat. It was excerpted in Orion, the environmental magazine. And what I love about this chapter, it's in the Arctic, and it's people who are working to restore degraded peatlands, and they're doing it watching the world around them change, the slumping permafrost, and they're trying to put an ecosystem back together. What was so interesting to me about it was that they aren't trying to go back to a 1950s sort of world. They're asking, what can we reconstruct that will survive in the future of climate change with warmer temperatures and less snow? So they're looking at ways to create wetlands and eventually to restore the peatlands that were there, but it's more of a rewilding approach than than trying to put everything back in some ideal way. So that was a fascinating chapter for me, watching them struggle with how to restore systems in a changing world.
Well,
And
it's
then,
certainly, sorry.
Well, go ahead, Andy.
No, I was just going to say that's certainly a practice, or it's an essential part of the journey in this century, is what you're describing. Even in agriculture, setting aside the methane question, you get, like in Brazil, there's vast areas what's called, I think it's called capoeira. It's land that's abandoned agricultural land that it has a future. And what we do with that, same thing in Central America, there's a lot of this as well. As what we saw in the United States as agriculture got concentrated, sometimes that leaves things unutilized. And those conversations for rivers and streams and everything around us seems so important. Do you think about this, Michelle? I mean, Sylvia, when you're out of the lab, are there other parts of your life that focus on some of these questions, or?
Well, I guess what Rob said about trying to cultivate optimism, because when you're in this business, it can be pretty overwhelming, and we're in it, and I got kids, and sometimes it feels pretty heavy, and so to try to cultivate that optimism by spending time outside and seeing sort of the opportunities to, appreciate and preserve nature, and feel like there can be hope for the future, even if the future looks a little bit different.
Absolutely. The idea of exposure to possibility, even whether it's nature in its untrammeled state or kids doing a stream repair project themselves.
Yeah.
Getting students engaged in this possibility that can happen in a city. There's some expression. My brain is slowed down. It was in Walden, or Thoreau said something at one point about the swamp at the edge of town being as valuable as the wilderness.
Mm-hmm.
And that's everywhere. And I've written about cities like Seoul in South Korea, in this megalopolis, where they stripped away the cement and the asphalt and restored a little stream through the middle of the city. And
I've been there. That's a really neat spot.
It is a neat spot. And I wrote a page one piece for the Times about that. There's a comment that came in that's pretty interesting. It relates to, whose behavior needs to change. Joe Hopfield says, at this point, it feels less about human behavior and more about the emergent behaviors of corporations, billionaires, and other concentrations of wealth. Yes. So maybe, Rob, how do you think about that? You're at Stanford. You talk to some of those people.
Yeah, no, I mean, first of all, spot on. It is important to talk about individual behavior and things that we can do, but it's not sufficient to talk about that. We have to talk about the system, the incentives. I don't believe that people in corporations are somehow inherently, worse or less ethical than people in academia or at NGOs. That's not my experience. But the incentives are that corporations, as long as pollution is free, as it is in much of the United States, then any climate solution is likely to be more expensive than free. Anything you bolt on that stops the emission of a greenhouse gas that can go to the atmosphere for nothing is going to cost a little bit more. That's why another chapter I love in my book was a journey to the first steel plant in the world producing steel without fossil fuels. It's in Sweden, and the company there has gotten rid of all of its coal, and they have replaced it with hydrogen that they generate on site using clean hydropower. And it's a really it's a marvelous example that's technological advancement that's helping their company. It's called Stop the Steal for stopping steel-based fossil fuel emissions. Yeah. But what's so interesting about it is that the only thing really that made it possible was a price on pollution. Sweden and Finland were the first countries in the world to pay for pollution. So they had to pay $65 a ton to emit carbon dioxide. They released a couple tons of CO2 for every ton of steel. And so that incentive allowed them to reconfigure their entire manufacturing process to clean it up And of course, it takes decades to spread that worldwide in their operations, let alone others. But carbon pricing or paying for pollution is, to me, the only way we will ever see global solutions for climate change.
And that's where I think things like the explosion of remote sensing capacity have made a big difference, because it's harder to fudge your numbers, whether you're a country or a company. I was writing over and over again about infrared imagery as a way to ground truth that anyone in a community actually can do if they can rent one of the appropriate imagery cameras and the like. And certainly at the satellite scale, we now have this capacity. So the more you can enforce and have a clear market, and that's part of that, the better the chances are you can monetize it. At least honestly, there's a lot of dishonest monetization going on these days.
And speaking of dishonesty, in Joe's comment, there are clear cases of companies that are obfuscating and working against climate solutions. So I don't mean to imply that every corporation.
Oh, no. I don't think anyone would presume you're implying there are no bad actors. There definitely are, and the same at the international scale. It's
there are plenty of good actors in the corporate world. I guess that's what I would say.
Yeah, and I think one of the things there is, what can we do to not lump everyone together in a sector? The same like in Brazil. I was recently there again, and around Belém, there's an organization in Belém that shows that you can have. We're not going to end beef anytime soon, but there's clear cases, and Dan Epstad has done publications in Science and other journals on this, where you get more beef from less forest. You can stop that connection between beef production and forest destruction, and that feels like the more of that, the better. But if we lump all in agro industry into one bundle in our heads and think it's us and them thing, that gets lost. Hold on, my dog is doing some barking. Rob, because you're at Stanford, and I'm not so sure, Sylvia. I see you Boulder, and there, Boulder is just such a science town, and like, what are young people you run into thinking when they? Do you think there's a need for more systems approach, so we're not just villainizing some industry sector and or the like? One reason I ask, Rob, is because I just did a conversation recently with some students at Stanford. It was really interesting. If I could share it here. Hold on. There are students at Stanford who work for Exxon. They actually have Exxon grants, and then there are others who are very much, no fossil fuel money on campus. And they had this conversation.
Mm-hmm.
They were showing the ability to sort of work across their own mental models and come up with a way to prompt the university to think about carbon cash on campus. Yeah. I don't know if you were involved with any of that, but it was just really interesting, because to me, it's sort of an outlier in the sense that we tend to be us and them, yes and no. Have you seen much of that, or do you see any of that in and around Boulder? Or
I do, and in fact, the New York Times had an article about that conversation with one of my students, Unai Kashtan, and one of Unai's friends, who came more sort of out of the petroleum engineering side of the school, if you will, and they had very different views. And I think those different views are reflected in the real world. To what extent do we need energy companies, fossil fuel companies broadly, to make the climate transition, the clean energy transition? And there are other people who believe that, we don't need those companies. They've hindered progress, and many people want to see those companies put out of existence. And I think that's it's a conversation that needs to happen. There's a tension there, and there's some place in between, in my view, we need to get to. And that was the core of your conversation and the New York Times article as well.
Yeah.
Well, I think, identity politics, we've been so divided. So the last thing we need is to have like these, hippie environmentalists on one side of the equation, and then fossil fuel burning pickup trucks on the other. Like, it's a problem for everybody. So like, let's try to come together and find common ground. I think at least these days, there's more awareness and acceptance of the problem, right? So, and you know, in Boulder, we're driving plenty also, right? Like I like to go skiing in the mountains and I'm part of the traffic. So yeah, I think we need to really work proactively to not villainize, not demonize each other, but actually just like look for common sense solutions that are practical, right? And, you know, telling everyone to go vegan is probably not reasonable, but also asking people to change their diets a little bit might be, right? Or, you know, to just set, you know, give them the awareness of, you know, there are consequences to, you know, where you are getting your meat from, right? So I think that we can find some middle ground, but I think we can't if we're just shouting at each other, right?
Yeah.
Or you know, calling each other names, right? Like that's not going to build any consensus.
No, I know, especially going into these next years.
For sure.
It's going to get really weird. And there's a role for courts and everything. You know, the Biden administration did put in place some methane rules and regulations that are probably going to be fought. Although I think even there, some people in the industry are not so eager for everything to be completely upended. Again, it's not unitary, and we'll see how that all plays out. There's another question that came in. It's an interesting one about rhetoric. I'm not sure who the reattached retina is, but he or she says, wouldn't it be better to use a term like methane surplus instead of budget? Budget makes it seem as if methane or anything else the word is used with is under control and in hand. It's interesting.
Yeah, so fair. The whole question of vocabulary is really important. Another reason why we need the behavioral sciences. I guess we use the term a budget, trying to use it. It's not a great term. We try and use it agnostically, which means we're summing up the sources emitting methane into the atmosphere, and we haven't talked at all about the sinks, the things that destroy methane in the air, because those change too, like they did during COVID. So we put all those pieces together to create a budget. Is that the best term to use for to promote action? Probably not. So, you know, it isn't just about the methane surplus, though. We need to understand methane destruction. How fast?
That's really, yeah. So it really is a budget.
We're just in the red in the budget, right? Like we're.
And an example of that was COVID. The 2 years with the highest methane increases on record were 2020 and 2021, and a major part of that increase was a decline in NOx emissions from industrial activity, which reduced the abundance of hydroxyl OH radicals in the atmosphere that destroy methane. So we really have to understand in your bathtub analogy, Andy, we have to understand the spigot and the drain to put these pieces together.
As we call them, excuse me for interrupting, we call them the gazintas and the gazoutas, right? Like what goes into and then what comes out, right? And so it's the balance of those that, you know, clearly because we see methane increasing, like clearly the sinks are not keeping up with the sources at this point.
That's so interesting. Yeah. And that, by the way, that paradox of a bad thing being something that is related to a good outcome is there in other parts of the climate system too. Aerosols and temperature, you know, there's negative. Even there's work recently that shows that aerosol dynamics are partially responsible for the uptick. Actually, the main driver of the uptick in Atlantic hurricanes isn't so much CO2 as it is or the cleanup of particulate pollution. This is work by a bunch of people. Yeah. And that gets complicated in a hurry. I want to go back to because you're talking about the innies and the outies. I know I got that wrong. To the idea of this part of what you're doing, Rob, which is, let me get rid of the comment. Thank you, reattached retina. You know, are there active ways to look at the whole system and get the methane under control? Maybe just talk a little bit more from the chemistry point of view of how this might work, and maybe distinguish the scale the potential scale with that of CO2 removal.
Sure. So for methane, the things that destroy it naturally are microbes. Both emit methane under wet, warm, and low oxygen environments, like a wetland or a rice paddy or the gut of a cow. They also eat methane for energy. They consume it in drier soils. So that's one way that methane is destroyed. So that window means that there are microbial species that might be cultured or enhanced to increase methane destruction. So there's an area of research in that field. The bulk of methane, though, is destroyed by the detergents in the atmosphere, the hydroxyl radicals, the chlorine radicals that clean up the pollution that we emit to the air. And to take one quick diversion, methane has this really cool interaction. It's the only greenhouse gas that when you emit more of the pollution, more methane into the atmosphere, it actually means that the methane lasts longer in the air. And it's a bit like a sink at Thanksgiving. You put soap into your sink, and if you keep bringing dirty dishes into that warm water and soap, eventually you've got to add more soap to clean your dishes. And the atmosphere is like that. As we keep adding more and more methane, the methane has to wait longer to bump into a cleansing radical.
Huh.
Or alternatively, if we reduce methane emissions, we'll actually see the lifetime of methane shorten. So sorry, that's a divergence, but
no, it's not a divergence really at all. It relates to the big picture. Yeah.
So the other way that people are looking to destroy methane is to mimic the catalysts and the radicals either in the atmosphere or industrial facilities or reactors that destroy methane. So there are catalysts that companies have been using to turn methane into methanol, which adds one oxygen to the molecule, and adding two oxygens gives you carbon dioxide, which is the ultimate fate of every methane molecule in air. So methane removal is really oxidizing methane to carbon dioxide, because that's what happens to every molecule anyway. It's expensive, it's hard, we can't do it yet at scale commercially. So we don't have to rely on it, but there's a lot of work happening that I'm part of and excited about. But first and foremost, we need to keep it from going into the air.
Absolutely. And, we're almost at the end here. Let's see if there's any other questions.
While you're waiting, that picture on the right I took, that's from the peatland system in Finland I mentioned.
Interesting.
In the chapter.
Peat ecosystems are amazing. We've been there now. Here we're in Maine, where I live. There's some extraordinary bogs, and over on Blue Sky, that social media network, the new one, there's a whole peat discussion going on. It's interesting. Though we didn't really talk about the agriculture question. We probably could before we end, and so it is a big source, and we mentioned beef earlier, but is that an arena where technology might also play, not just in the general drawdown from the atmosphere, but more directly?
I think it can. I'll answer briefly and then turn to Sylvia. I have another chapter in my book called Planet of the Cows, and I interview Pat Brown, who founded Impossible Foods, who wants to
been on this show.
Yeah, who wants to put industrial, food production industry out of business. So you can think of climate solutions as reducing the number of emitting widgets or organisms, or we can reduce the emissions per cow or facility that's left. And I also interview Ermias Davis, who's looking at feed additives. And there's a lot of exciting work that tiny amounts of feed additives, be they algae or other things, can reduce methane emissions by 50, 75, or even 80 or 90% or more.
Right.
And they might even boost the growth for the cows a bit, or dairy production, because that methane has lost energy. The problem is that most cows are on the range, some are in a feedlot or in a dairy, and those we could feed daily, but rangeland cattle we can't. Right. So there are other people looking at vaccines and engineering microbial communities. So there's a lot of good things happening in the cattle emission space. There's a lot of investment finally going to that area. So we need to both reduce the number of cows, exactly like Sylvia said. We can, in rich countries especially, we can eat less beef and dairy and be healthier. But we also need to reduce emissions per cow for however many there's 1.5 billion cows on Earth, whatever the number comes down to, they'll still belch methane.
Absolutely. There is another question here, and thank you both for hanging in there today on a Friday. From LinkedIn, a user says, can you touch on the geopolitical dimensions of the problem? What levers are there to affect emissions in countries lacking legal systems that make transparency and accountability possible in most democracies? Well, we kind of touched on a little bit of that in terms of transparency, imposable transparency. But is there anything else that comes to mind? Rob, I mean, this may be outside, Cynthia.
Definitely outside my expertise here.
Yeah, but Rob, you've dealt with the treaties.
Nothing like ending on an easy question. This is a hard issue. The beauty of satellites, we've already talked about, the ability to see emissions around the world. The handshake from information to action is not simple, even in the United States, let alone in other countries.
Right.
The first satellite that ever looked at emissions is GHGSat, a Canadian company. And they had this great example where they found a huge source in Azerbaijan. And they contacted the company, didn't hear anything for years, a couple of years, I think. They eventually went to the embassy. The couple of years part of that may be wrong. They actually went to the embassy and contacted the country at the major level that way, and eventually got something done that way. But it took months to years to make that emission go away.
Yeah.
So that handshake of information to action is not straightforward, even in the U.S.
Yeah, and less so in many other parts.
And less so in the kinds of countries the LinkedIn user refers to.
I just want to add the point that I think the satellites are so powerful, but Rob mentioned how the surface-based monitoring is really like the ground truthing of, the satellites can see in places where we can't take air samples, but we need the air samples to ground truth the satellites. So they really are complementary approaches. But yeah, it's the air it's not affected by the glint off the ocean, right? Or the clouds blocking the measurement from the satellite. So I thank you for speaking on behalf of the air samples, which is sort of the old school method of measurement, that it's not very glamorous, but it's sort of sustains what we do and is sort of the backbone of what we know about the atmosphere.
Yeah, we call the atmosphere the truth in the Global Carbon Project. That's what we know is real, and everything else is an information or kind of an inkling into the truth.
That's so
and the satellites give you the bigger picture, but it's hard. Like you need to actually measure the air to know if the satellites are telling the truth, right? So.
Well, this has been a really great discussion. There's one more question come in, and there's quite a number of people watching, which is really nice. And of course, everyone can share this as soon as we're done. Mark Ferguson says, we're using methylotrophs to destroy, we call it oxidization, methane produced from manure via anaerobic digestion into a near zero emission fertilizer. Wow, so that sounds like a double win or something. Is this a technology, Rob, you've been tracking at all, or can I look it up?
I think the word we would use is methanotrophs. So methanogens generate or emit methane. Methanotrophs eat trophic levels being consuming. And so I mentioned this a little while ago. There are these classes of microbes that consume methane as a source of energy and for other reasons. And people are culturing them, using them in digesters. Some landfill facilities are doing this. Some facilities are actually capturing that methane that's generated and converting it to electricity or trying to convert it to fuels. So it's a great example, and there's more and more of this happening. But again, there has to be some nudge for making this happen, right? Is there a payment associated with that? Can they make money doing it? Is there a fee to emit that methane if they just let it go to the atmosphere? So it's a combination of the market and regulation.
Or can we end up with a consumer class that's sufficiently inspired to think about a low emitting product that they demand that product? This is such a challenge. With students in 2011, a documentary on shrimp farming, and there are these really good approaches to shrimp farming that are wonderful and they have low impact, etc. And but if you don't have a consumer who can go to a market and know and care that there's different kinds of shrimp, or beef produced with no methane, additional methane, then I'll flip that around. If informed consumers can know that, and you have that clarity, then we can drive industry potentially without necessarily a carbon price, where it's the benefit is clear.
That's a great point. Sorry for jumping back in. I think there is the opportunity in voluntary markets. I guess I would just like to to highlight the fact that I can do that, and most listeners on this program can probably do that. But there are a lot of people who can't afford that, who pay a higher price for climate change, and they can't afford to pay more for that hamburger or whatever they're eating. And I guess I think of climate solutions and clean energy first and foremost as a health issue. So clean energy makes all of us healthier in richer countries, in poorer countries, in poorer parts of richer countries, and that's increasingly the vocabulary or narrative I try and talk about with clean energy solutions. It's really not about some future generation. It's about the 10 million people who are still dying every year from fossil fuel pollution around the world.
Absolutely. And so this, at the same time, the last thought I might interject, and then any final thoughts from you both would be great. When you mentioned you were at that retreat with the behavioral scientist, his interest was in a technological fix, which essentially would make it so the solution so cheap that people with our existing habits would absorb that solution. And you are talking about the hope of these wider approaches too. It's kind of both. We need technological innovation for sure, and markets and the prices on negatives can definitely drive things in that direction. General awareness can drive things in that direction, but a lack of awareness is what is problem. And that's why it's been great to have this conversation today with both of you. Sylvia Michel at CU Boulder, and works with NOAA people on the methane, the mystery and the options revealed by science looking at methane sources using advanced isotopic chemistry, and Rob Jackson for decades, a very wise voice and impactful researcher at Stanford on the climate challenge. Thanks for being on here. And as soon as we're done, this can be shared anywhere, the video, and I'll update my post that was on my Substack thingy, and people can read about it there. And maybe we can do this again sometime. I just really appreciate your being on Sustain What.
Thank you so much for inviting me. This has been a pleasure.
Same, Andy. Thank you so much, and great to hear from Sylvia too. Thank you all.
Hold on one second.